Hello and welcome to another session in IBDP MAI HL course. And today we are going to talk about SL 1.5, which is laws of exponent and logarithms. For IBDP MAI SL level, we have the laws of exponent and some properties of logarithm along with its definition. But higher level problems will be asked in MAI HL part only. So you can also use your GDC in order to solve the numerical based problem, but sometimes definition is also important because if they ask for the unknown value, then you have to use the definition. So as you are already familiar with the laws of exponent, like if you have a and b whole raised to the power m, then it becomes a to the power m, b raised to the power m. Or if you have a by b whole raised to the power m, so you can rewrite it as a to the power m over b raised to the power m in both ways. After that, if you have some a raised to the power some, let's say x, and multiplied by b, same a, base is same, raised to the power y. You can rewrite it as a raised to the x plus y, correct? If base are same, powers gets added up if they are in multiplication, and if they are in division, then base same makes it a raised to the x minus y. Okay, so if you have something like a raised to the b, here this a is the base and b is the exponent. Okay, now after this, if you have exponential function of some function, like if you have a raised to the power x, okay, that's your y. Another way to write the same thing in the logarithmic form is what means we can also write the same thing, but this time let's find the value of x, for example. Okay, so the value of x from here can be written as log of y to the base a. Okay, both are same, so always remember this definition, please. Okay, so now if you have some y equals to log of x to the base a, where remember this x must be always greater than 0, the base a must be greater than 0, as well as base can never be equal to 1, otherwise it is no longer logarithmic. Base is not, if a is equal to 1, then this logarithmic function is not defined. Okay, and for exponential, if base is 1, then it is no longer exponential, right? If here if you put a as 1, it is no longer exponential, it will become a constant function. So that's the definition. Okay, now after this remember two more things. If they gives you log of x only, or if they says ln x, so what that means, log x, if the base is not given, so we always considered that base as 10. Even in your GDC it automatically takes it base 10 if base is not given. Or if ln x is written, it means it is natural log of x, so it means the base is e. What is e? E is an irrational number and its value is around 2.71848828 something, so on. So no need to memorize this value. The thing is, you have to memorize two things. E is a fixed number, right? It's an irrational number, as well as E is greater than 1. Okay, always remember this. E is 2.718, so it is a number which is more than 1. Okay, so if base is not given, it means it is 10. If ln x is there, it means the base is e. Base is considered as e. Now, so let's solve some questions which you may find in your exams in the IBDP MAI SL HL course. So let's start with this evaluation of 2 raised to the negative 2 whole raised to the negative 2. Okay. See, if you have a raised to the power, say, b, and whole raised to the power c, that means you have a raised to the power b times c. Okay, it is different from a raised to the power b and whole that b raised to the power c. These two are different thing. Okay, do not consider these two same. A to the power b whole raised to the power c is different. Okay, so in this particular question, what we have, first one, right? So in order to simplify it, can I write it as 2 raised to the negative 2 times negative 2? That makes it 2 raised to the 4, and 2 raised to the power 4 is 16. Okay, that's the one way to solve this problem. The other way, There are other ways as well. For example, you have 2 raised to the power negative 2. You can also write it as 1 over 2 squared, right? Whole raised to the negative 2. What is that? 1 over 4 raised to the negative 2. Again, you can write it as, this will go into the numerator, okay? So 4 raised to the power 2, that is again 16. So both gives you the same result. So it doesn't matter which method you use here. Next one. As I said earlier, 2x whole cube. Two numbers are there in multiplication and its whole power something. So power get distributed to each. So 2 to the power 3, x to the power 3. That makes it 8x cubed. Okay. After that, it says solve this one for the value of x. You remember, we can use the definition of logarithm because it's an exponential function. Okay, so from here, if I use the definition of the logarithm, I can say this value gives us x equals log of k to the base 10. Since this time the value of k is not given to us, so we can leave our answer here. So the value of x is log k base 10. If they gives you some particular value of k, so corresponding to that value of k, you can use your GDC and put that. Okay. For example, if they says solve 10 raised to the power x plus 5 equals 7, something like this. So if I use the definition of the logarithm, I can say x plus 5 is equals to log of 7 to the base 10. Now using the GDC, I can find what's the value of log 7 base 10. Simply use your GDC and it gives me log base 10 because and the value 7. It comes out as 0.84509. So I can write it this. Okay. So what's the x? X equals to this value minus 5. That comes out as minus 4.1549. So I'll write it 155. That's the value of x. That was another example. Okay. Now, next one says e raised to the 2x minus 6 equals 5. Find the x in terms of natural log of, right? So no need to use calculator again. Okay, you just have to write the expression only. So if I again use the definition of the logarithm, I can say 2x minus 6 equals natural log of 5. So what is x? On simplifying, I can say ln 5 plus 6 whole divided by 2 is the value of x. That's my answer. Okay. So next part is evaluate log 10 where base is e plus log where base is 10e. Okay. So this is find the value of this using the GDC. So in the GDC, if you enter these two values, log of 10, natural log of 10, you can use your own calculator and verify your result with mine. Okay. So natural log of 10 comes out as 2.30259 plus this time log base 10 for the e. E is an exponential number as I said, e. So put it here. I'm getting 0.434294. Now add these two numbers. Okay. So when I add these numbers, I'm getting 2.73688. That's the numerical value. As I said, if numerical numbers are given, you can use your GDC to calculate that. Okay. In the previous, they clearly mentioned that you don't have to use the GDC to calculate its numerical value. They says find the value in terms of natural logarithms only. So that's my answer. Okay, that's why that was my answer. But this time, this is my answer because I have to calculate this value for decimals as well. Okay, if I write my answer correct up to three significant figures, so I can write 2.737. So it is four significant figures. Okay, or you can say 2.74 for three significant figures. Okay. Now, so in this session, what we have done till that part, we have covered exponential functions and their laws, right? After that, we solved some questions based on above rules. And then we did some questions on definition of the logarithm, and I also explained what happens if the base is e. Okay, you can use your GDC and remember how to find the difference for the values in which either natural log of x is given or common log of x is given. So first one is the natural log, and log, if base is not given, this is called common log, and base is considered as 10. So that's it for this session. I hope you got all these. If you have any other doubt or any other question, you can contact us or write down your question in the comment box. Okay, I'll see you all in the next session with our S1.6 topics. Thank you for watching this. Keep watching, keep learning.